This conference will now be
anticipated,
recorded.
something like in the quarter end or month end. So month end or quarter end, if you have a huge workload, you already know that, and it needs about 2 clusters or 3 clusters, right? You can start your virtual with these 2 clusters, and then this can be configured. Then instead of using a regular cluster, you can point them to a multi-cluster with okay. And when you have it, you make minimum 2 and then minimum cluster is 1, something like this, right? Then this is called auto scale mode. Okay. When you set up what is an auto scale mode, the minimum and maximum clusters have a different number. Minimum will have a minimum number and maximum will have the biggest number. So if you are trying to create with 5 of them, right? And then you can have 2 of them here. So 2 will start, and then the next third and fourth and fifth will start in auto scale mode. Okay. So this is what is called maximize auto scale and maximize mode. Okay. So we have already discussed it, right? So multi-cluster warehouses, they are used for concurrency. Too many users logging onto the system. It's not for performance. This is called scale out, scale in, scale out for multi-clusters. If you are adding additional clusters, that is called scale. And automatically, whenever there is no load on the system, it automatically scales down. That is called scaling. Okay. And if you're trying to increase the size of the cluster, whether it's a single cluster or a multi-cluster, that is called scale up. And when you resize it to a lower one, that's called scale down. Scale up or scale down. Scale in, scale out. Scale in means cutting down the multi-cluster to a normal single cluster, or to automatically based on the load, it adds clusters to do the load balancing. Okay, and then I'm not able. The close this is not responding to me. So the next thing is the scaling policy. So scaling policy is something whenever we are trying to create a virtual business, right? We have 2 policies. One is standard and one is economy. You have to remember these 2 names when you are trying to write an Snowpro examination. So standard and economy. When you create your, or when you are trying to, let me go ahead and configure, right? This is called the scaling policy. Standard and then economy. There are 2 of them scaling policies. So economy is something like misery system, and standard is like much more flexible with the load. So let's go and look at the differences here. Okay. Prevents minimizes queuing by favoring starting additional clusters over conserving credits. That means normally when you are trying to start a virtual warehouse is started and you are running your queries on it. And the moment the first query is executed, it allocates a resource, right? And if it thinks that the next query that is coming up might not have the enough resources, then it goes and spins another cluster. It doesn't look for the creates part of it. It looks at the performance part of it. That means it doesn't want any queries to be queued up. If that is the scenario, it goes and spins up another cluster that is called a standard policy. So when immediately as soon as a query is queued, our system detects the currently running clusters can execute. That means that is coming onto the virtual warehouse, and if it doesn't, it spins up another cluster and then it runs that. Okay. Battery, hold on. So how does it do it? So this is the starting of the cluster. And how does the cluster get shut down? Because scaling it the least shutting down the cluster, it identifies loaded cluster because the queries are getting distributed. It goes and identifies which is the least loaded server. That means which cluster has minimum number of queries being run. And if it sees that if it can accommodate those two queries in any other two clusters, for example, we have three of them, and one is fully, and the other one is full, and third one is running right now. After a while, the first one and the second one, some of the queries gets executed, and third one is still running. So that means first and second will have some resources available for executing the queries. So if that is the case, it goes and looks at the third one, least loaded, least running queries virtual warehouse, and then it doesn't allow the queries onto the least loaded one. It accommodates the other queries coming onto the first and second, and then once all the queries that are part of the least loaded workhouse warehouse gets executed, it shuts down that particular cluster. Are you able to follow me? Yes, you need to speak to
Yes,
me,
I can.
please.
Yes.
Yeah. Okay. So that is the case. That means it goes and checks every 2 to 3 seconds. In an interval of 1 minute means every two three. Sorry, in an interval of 1 minute means every 2 minutes it goes and checks how much is the load on the virtual warehouse. Then it looks if any of the new queries coming up can be accommodated on the other virtual warehouses, and it leaves the least loaded virtual warehouse apart, and then gets all the queries being executed into that. It doesn't allow new queries onto the least loaded virtual warehouse, and then it shuts down. So it tries to poll every 2 to 3 minutes and check how much is on the virtual warehouse. This is what it happens with the standard policy. When it comes to the economy policy, right? Economy, if the virtual warehouse is fully loaded, it even waits for other, it knows how much time it has spent on the query and how much when is this query being done. That means if it has 10 queries, it knows the two queries are going to be finished very soon, and then it tries to keep queries in the queue for some time, and then it keeps checking for the load for almost 6 minutes. Okay, so it goes and checks if there is enough query load of the queries that are being run, and all those queries more than 6 minutes. it knows the queries are being run, right? It goes and checks all the queries and the get finish time duration of the queries. When will this query get finished? And if all the queries run more than 6 minutes of time, then it cannot accommodate. So it spins another cluster. Little misery. This is called economy. Okay. Just the reason is every 5 to 6 minutes, rather every 2 to 3 minutes, this particular economy policy goes and checks for. Okay. So the least loaded virtual checks instead of 2 to 3 minutes, the polling duration in frequency is 5 to 6 minutes, and it least loaded server. Sorry, which least loaded virtual warehouse. It stops taking new queries onto it, and then it shuts down. Are you clear with the scaling policy? And the default policy is standard.
Can you explain economy, Shekhar, again?
So economy is right.
Yeah.
Whenever you set it in the economy mode, it doesn't start the new cluster very fast. What it does is right,
Mhm.
it waits even the queries queue. It, how long does it wait? It goes and checks how many queries are there running right now and when they can be completed. If they can be completed within 6 minutes of time, then it doesn't spin up a cluster. If the query, if they're going to take more than 6 minutes of the time, it spins up a cluster.
Okay.
So it checks how does it know whether the queries are going to run more than 6 minutes? It checks for every 6 minutes. The polling frequency to check the load on the virtual warehouse, the frequency is 6 minutes. Now, the
O-
moment new query comes onto the virtual warehouse, right? It looks at the load on the virtual warehouse, and then the next frequency is 6 minutes, and it checks after 6 minutes. In after 6 minutes, also, if there is no space, no resources available on the virtual warehouse, it goes and spins up another cluster.
Okay.
And the same thing happens when it's trying to shut down the cluster as well. It goes and checks every 6 minutes, and if the least loaded warehouse, if they it keeps them, and the other where they can accommodate the queries, right? It accommodates the new queries onto the existing one, and it doesn't disturb the least loaded virtual warehouse. It waits until all the queries are done. It does uh, use that cluster for the new queries, and it makes all the queries to be finished, and then it shuts down the cluster.
Okay. Okay.
Got it?
Got it, Shekhar.
So yeah, any question for me?
No question, Shekhar, for me.
Sorry, I couldn't hear you, Bhaskar. Come please.
Nothing, Shekhar. I'm good.
Right, okay, right. So let's go and do some sorry. Let's go and do some calculations. But whenever you are trying to use a multi, you can resize the multi-cluster as well. Even if it's running, resizing multi-cluster meaning if your multi-cluster has been created on extra small, you can change the size to small or medium, even though it has many clusters in it. So you can resize a single cluster, you can resize a multi-cluster. Okay, so let's do some calculations and then. Okay. So and the credits that are you are going to be charged is for the number of hours or the duration by which number of clusters ran, not the number of clusters that you have configured. You would have configured 5 as max and min as 1, but your load would have required only 2, and you are charged for 2 only, not for 5. This is an interview question as well as Snowflake question. Remember this. Not the number of clusters, max clusters that you have configured, but the number of clusters that it ran in the duration of time. Are we clear? So for example, the maximum number of credits consumed per hour for a medium size warehouse. Medium is 4. Okay. With 3 clusters is 12 credits. Okay. If 3 of them runs for the entire 1 hour, then 12 credits. So first one is maximized mode, 2 hours. In this example, a medium sized warehouse, 4 servers per cluster, with 3 cluster runs in a maximized mode for 2 hours. That means how many clusters are there here? 3 clusters. And how much duration they ran for 2 hours. The first hour, 3 clusters, 4 credits. Because it's medium, right? Second hour, 4. Total is 8. But the first cluster, second 8, and third is 8. Total is 24 credits. Are we clear? Maximized mode meaning all of them will start at once. Okay. So coming back to the other, so auto scale mode. Auto scale means 2 hours. The first one starts, and then when there is load on the first cluster, and it spins another cluster. Okay. In this example, a medium sized warehouse with three cluster runs in auto scale mode for 2 hours. Cluster 1 runs continuously. Cluster 2 runs continuously for the second hour. Cluster 3 runs 30 minutes during the second hour. So cluster 1 for first hour, second hour total 4 and 4. Cluster 2 runs continuously for the second hour. So first hour is 0, second hour is 4. Cluster 3 runs 30 minutes during the second hour. That means 0, and then the 30 minutes means half of 4, right? It's 2. Total is 14. Are we good?
Shekhar,
So
one
auto
doubt.
scale. Okay.
Just can you go back to that?
Do you want me to go back to another slide? What is slide number 13 or 14?
No. Okay. Here only. Actually, cluster 3 runs for 30 minutes in the second hour only. But it is
Yeah.
given it as third hour also it is running, right?
No, the whole thing runs for third hour. Cluster 3 runs for 30 minutes in third hour. In the third
No,
hour,
slide 13.
it's, yeah. So sorry. Cluster 2 runs continuously for the second hour and 30 minutes in the third hour. So cluster 2 was utilized only for 30 minutes in the third hour. And cluster 3 runs for 30 minutes in the third hour. So that is the reason third hour, if you look at it, cluster 2 is only half of it because it ran only 30 minutes. 4 by 2, 30 minutes. Entire 1 hour is 4 credits, half hour is 2 credits. And cluster 3 runs only 30 minutes in third hour, 2. So that means 20.
Okay, got it.
So this is another example. Warehouse, for example, the auto scale mode for 3 hours with the resize of medium. That means they have resized from medium to large. Medium is 4 and large is 8. Okay. Cluster 1 runs continuously Cluster 2 runs continuously for the second and third hour continuously. Warehouse is resized from medium to large after 1.5 hours. After 1.5 hours, the warehouse is resized. So out of the entire duration of 3 hours, the warehouse was run in 1.5 hour in medium and 1.5 hour in large. Okay. And then cluster 3 runs 15 minutes in the third hour. So let's go and look at the cluster 1. Cluster 1 for the first hour, how much is it? It's a medium, 4. And cluster 1 for the second hour, 30 minutes in medium and 30 minutes in large. So for medium, it's 30 minutes means 2. And for large, 30 minutes is 4. And then the third hour, it runs completely, right? So it's 8. Are we clear? And then the same with cluster 2 runs continuously for second and third hour. Second hour, same scenario. First hour 0, second hour half of the time in medium, half of the time in large, 4 plus 2. And third hour continuously 8. And cluster 3 runs only 15 minutes. So when it comes to cluster 3, what is the size of the warehouse? It's large. That means for 15 minutes means for half an hour, that is large already. Half an hour for 15 minutes 2 credits. So total 30. Okay. You understood this one, right? Are we good? So how do we create a multi-cluster warehouse? Multi-cluster is warehouse nothing but if you give your min cluster, max clusters bigger than, if you specify a max cluster and the min cluster is 1 and max cluster more than 1, that becomes a multi-cluster. So create or replace warehouse with object properties and object parameters. Warehouse size is equal to so and so sizes. Similar, you will use max cluster count, min cluster count. That's where it becomes a multi-cluster. Scaling policy, standard, economy, auto suspend how many minutes, auto resume is it true or false, by default is true, and initially suspended is equal to false. That means it will run. The moment you create a virtual warehouse, it starts running. And then resource mount is another one. We'll talk about it later. And max concurrency level, statement queue. This things we have already spoken. So create or replace warehouse, my warehouse with warehouse size is another example. In the maximum clusters field, select a value greater than 1. In the minimum cluster field, optional select a value greater than or equal to 1. So this one. Maximum is greater than 1, minimum is greater than or equal to 1. It's optional. Okay. And you can create a virtual warehouse using the SQL as well as the web UI. So when you're trying to create a virtual warehouse, you don't use the keyword virtual, you say create or replace warehouse. Okay. Increase or decreasing clusters for a multi-cluster warehouse. Okay. This is just an alter example. You can go and configure this virtual warehouses, configure and then change this or alter warehouse. You can rename it to a different warehouse name. You can resume it if it is suspended, and then you can resize to medium or small or whatever. Okay. So what happens? Effects of a resizing of running warehouse. We have already spoken about this. 1 second, English. My dad is coming. So servers added to warehouse start using credits when they are provisioned. Okay. However, the additional servers don't start executing schedules until they are all provisioned. If you have a multi-cluster, first it starts with one in auto scaling mode, and the other two are not provisioned. If you have a multi-cluster that you have designed, max is 3, min is 1. So it starts with 1. The other two are idle. They are not used at all. Unless until you have a load, then only they get provisioned. Okay. So servers are removed from warehouse only when the servers are no longer being used to execute any command. So here, if you look at it, right, it's cluster is a logical term and server is a physical term. That means whenever it spins up a cluster means it adds additional servers basically. So when you have a small one, right, of 2, we have created a multi-cluster warehouse with 3 as maximum, 1 as minimum for a small size warehouse. So small size means how many servers do we have? You have 2 servers. Whenever it spins up a cluster means cluster is a logical word. It will start 2 more servers. When the third cluster is spin up, then it will start add 2 more servers. They are also called nodes. So it keeps on adding servers to it, but the servers which are being started is based on the size of the t-shirt of the warehouse. If you are starting up a medium, it will add 4 of them. If you start adding spinning up a small, it will start 2 servers. If you are extra small, it will start 1 more server. So cluster is a logical word, but physically the work is done by servers and it adds servers or the nodes whenever you spin up another cluster. Okay. So as we discussed before, right, the queries that are running on the resize before the resizing happens, whatever the queries are running on the previous size of the virtual warehouse, they are not moved on to the new side of the warehouse. They get executed on the old side of the warehouse, and the new queries that are coming up or coming in will be using the new side of the warehouse. Okay. So how do you monitor the warehouse here? Okay. Whenever you come to this particular thing, right? File, so this is called load monitor graph. Okay, and then it shows you how the load was there. So if you, so this shows the entire thing. Okay, let's go back. This is, you go to your you click on any virtual warehouses and click on virtual warehouses. It opens a chat. It's called load monitoring graph. Okay, and by default it shows for 8 hours with a 5-minute interval. Okay, and you see this slider, right? This one is for 14 days. I think it's 14 days. See, you can see 14 days, and if you can see this slider. You can scroll your slider for 14 days. By default, it is for 8 hours. This top level chart shows you for 8 hours. Okay, and then when you look at this, right, I don't have much of data that is for. So if you look at it, right, if you keep your mouse here, it shows you the load on the virtual warehouse. At 8 o'clock AM, it ran and the load is 0.01. And if you want to look at it, right? So how do you see? I'm not able to show you the, it ran and then from 8:10 to 8:50. So if you look at the frequency, right? This is on June 5th and it ran from that is hidden there, guys, but it's 8:10 to 8:15. So it shows you in a 5-minute interval. That means within 5 minutes how much is the load on the system. Okay. I have another thing. Okay. So this is what it is. If you look at it, right, 31st July and then 9:15 to 9:20. Let me run this. So if you look at it, right, 31st July, 9:15 to 9:20, 5 hours. Sorry, 5-minute interval. And in 5-minute interval, how much is the load on the system? Running is 4.21 and Q is 0.8. So how do you calculate this load? How much is 5 minutes? 5 minutes means 5 into 60, 300 seconds. And how many queries are being run? It goes and adds how many queries are run, the total duration of the queries divided by 300. Okay. So that gives you, so I'll show you another example. So there is another example. This load is important. So if you look at it, right, you have some colors here. And if it's queued, you will see an orange one. Green, running. Okay. And then, so these are the statuses. Running, queued, queued provisioning, queued repairing. Running means if the queries are being run on the virtual warehouse, that is. And if there are any queuing happening on that particular warehouse, then it's queued. Queued provisioning means you have submitted a query and the virtual warehouse is starting. You won't see this. I never saw these two things, these two statuses, but I've seen these two. Okay. Queued provisioning means you submitted a query, but the virtual warehouse is starting. It takes some time for the starting up of the virtual warehouse, provisioning of the virtual warehouse. At that particular scenario, you will see provision. Okay. And queued repairing means sometimes these virtual warehouses, because the hardware, right? You might have some issues with the hardware if that particular cluster is not starting up. You have some challenges in it, and the queries are being run on that. Then it will say repairing. Okay. Queries that were waiting while the warehouse repaired occurs. That means you assign these queries to a new virtual warehouse, but there is a problem with the hardware. It's not starting up. Then it shows you as query queued repairing. Occurs only rarely and usually does not last longer than a few minutes. Okay, this repairing. Typically, this provisioning typically only occurs in the first few minutes after warehouse resumes. It depends upon the size of the warehouse and the query that you are running. These are the 4 statuses. Okay, and then I'll show you how to calculate the query load. So there are 5 queries running in an interval of 5 minutes. How do you see 5 queries running in an interval of 5 minutes? If you go to the warehouse, sorry, query history, right? So we saw this on 8.5, right? So where is this warehouse load, right? And there is nothing here. I have moved here. So this is my load. Okay, I'm running 0.01, and so 810 to 85. Sorry, 810 to 815 is the frequency that is showing here. So 810 to 815 on what date? It is 5th of this. We run today in the morning. Yeah. So let's go back to the history, and then so there are some other things that is not reflected yet. 810. Where is this 810? So 810 to 815. So this is the frequency which ran, and this is the query selection from EMP. So how much duration it ran? Started on 8:14:14. It ended on 8:14:15. It ran for 1.6 seconds. The total duration. So How much is the total 810 to 815? So this is 1.6. So there is no 810. So you have to calculate 814, and then the next one is 831. So how much? 1.6. That means 1.6 divided by 300, 0.005. This is the load. That's how you calculate the load. But I don't know. It's not showing the other. So this virtual warehouse, right? It gets refreshed, and let me refresh. So there are things which are very negligible or something like that. So that is the reason it's not showing. This is the only one which has 810 to 815 running 0.01. So it's very negligible here. It's kind of very difficult for me to explain by showing my system, but I can talk to you from this particular example. Okay. So there are 5 queries that are running. Sorry, 5 queries that are using the virtual warehouse. 4 of them are running. Fifth one is queued. Query 1 running. It was running for almost 30 seconds. Query 2, 201 seconds. Query 3, 15 seconds. Query 4, 30 seconds. And if you want to calculate the running load, right? 30 divided by 300, because we are looking at a frequency of 5 minutes. 5 minutes means 300 seconds. 30 by 300 will give you 0.10. This one 0.67. This one 0.05. This one 0.10. Total running load 0.92. And this is queued for 24 seconds. 24 by 300, 0.08. The total is 1. Okay. So based on the frequency, you can, and whenever you slide your, if you pull your slider, right, the frequency changes here. And let me go and show you this slider. So now I have changed, and then if you look at it, right, you'll see 930 to 945. How much is the frequency here? How much is the duration here? Is it 5 minutes or 15 minutes? So whenever you pull up your slider, right, the frequency gets modified. So it shows the load from 930 to 945 on June 4th. So if you go to your history, June 4th, 930 to 945. Where is the date? So if you see this, right, June 4th, 930, how much is it from? 920 to 935. 920. So you have to add all these ones. So where is 920? So this is the one. So it is done in 915 from here 53 milliseconds, 34 milliseconds, 41 to 47, 49 until 935. 31, 30, still to 931. You add up all of this stuff divided by total, and then the frequency is 15 minutes. 15 into 60. A total 15 into 60. How much is that? Whatever that. That gives you the load on the system. Okay. So, and when you pull up your slide a little more, right? So the got here. So 850 to 9. The moment is the max is 1 hour load. So 850 to 950, it's 1 hour. 850 to 950. 750 to 850. So based on it gives you the graph on the 1 hour load. So 1 hour, it starts with 5, 10, 15, 20, 25, 30. It goes on based on your pulling up of your slider. And this is for how many days? 14 days. Okay. So we can make some we can infer some data by looking at the load of the virtual warehouse. Okay. So let me see what using the load monitor connections. Okay. Slow query performance. Whenever you're running your query, it was running very good in the previous sessions. Now it's taking a lot of time. What might be the reason? Because the virtual warehouse is loaded, overloaded, and your query might be in the queue. Sometimes your query exits and then without being executed. How and what is the reason for it? So you would have put your timeout, queue timeout in the other object parameters that we have seen, right? Queue timeout in seconds. If you have put it in 60 seconds, and if the query has waited more than 1 minute, and then the query automatically gets killed, aborted. It doesn't even run, and you cannot identify what is going on. Why is this query being not run? So you go and look at this parameter and then make the modification for this particular parameter. It can wait more. Okay, and then you have to troubleshoot why the queries are being queued, and you look at the query. What is is there any? So previously the query was running for only 100 GB data. Now the query is running for 1 terabytes or 3 terabytes data, because there was an upstream data or a movement or a, and there was a data movement of 10 terabytes in the same table. You would have ingested 1 terabyte. So whenever the data gets more, right, what happens? It automatically, so it automatically goes and then okay, it because so it becomes much more difficult. That means it takes a lot of time in the performance. So the running, if the running query load is high or there is queue, because if the load is high, that means the maximum resources are allocated for that particular query. So it doesn't have much resources to spend on the next query. So if the running query load is high, consider starting a separate warehouse and moving queued queries to that warehouse. The moment you spin up, you make it resize it to a multi-cluster warehouse, it automatically spins up a new cluster, and the queries that are being in the queue are now moved into the new cluster. That is the time that you resize your cluster, resize your warehouse. Or if it's already multi-cluster, then you can go and add more multi-cluster. And this is all done on the fly. You don't need to do anything. You go change on the fly, the queries get moved on to a new cluster, and load balancing happens automatically. There is no shutdown, startup, and all these things is not there. Okay. If the running query load is low, so if you look at it right here, the load is very high, and these are all queuing. Now you can go and then plan for running some of the queries on a new cluster and some of the queries on. So you distribute the load to a different cluster so that the queries won't get queued and queries get executed. Or you can create a multi-cluster and run things. And sometimes what happens, you have created a big cluster and you see a very low volume load on the system. Then you go and modify your size. Rather than running in medium, go ahead and run it small. That should be sufficient enough for you. Resize the warehouse, provide more computing. Okay. And then peak performance. If you look at a graph, load monitor graph like this, right? That means at some intervals you have a huge load. At some intervals you don't have a load at all. So consider moving some of the peak workload to its own warehouse and potentially running the remaining workload with smaller clusters. So you have to go and distribute the queries that are running on single warehouse. You go identify this particular warehouse, there are this many number of queries running at the same point of time. If you look at the frequency, you will have a 5 minute or 10 minutes frequency, and you will see almost 100 queries running on it. Instead of running on one single cluster, 100 queries, you distribute the load onto another, you create another one, and the queries that are running on one, you tell your developers are automatically, whenever the jobs are running in the back end, you go and then move some of them, which are taking a lot of time. You keep a lot of time running queries on one big one and create a small cluster, and then queries which are running fast, you run them on a different cluster. Or you can increase the multi-cluster. So this is all trial and error. There is no hard and fast rule. Based on the load of the system, you have to come up with your decision. So look at the history page and you will get to know what are all the queries, how much duration, how much data, if you look at it, right? So total duration, and then you will know byte scan. You'll see byte scanned as well, right? So byte scan, if it's more byte scanned, then that is a query it's taking a lot. So the query might be complex. I don't have an exact scenario to here. Look at the duration and byte scan, and then if you're running it from a third party client like a JDBC or Python or something else, you know this particular application here, and go look at the query, and then identify and then move. You have to do some manual work. You segregate fast running queries onto a different warehouse, and time consuming queries on a bigger one, and then you execute. It's all trial and error manual effort. Are we good on this? Are we good, guys? That is pretty much about virtual warehouses. Any questions for me, guys? I think I have pretty much covered a lot of stuff on the virtual warehouses. It's basically theory part of it. You have to understand what it is, and then probably you have to figure out. Are we good? Shall I proceed with another topic, or shall we start it here? It's up to you guys. So let's go back to so loading data into Snowflake, we have covered it. Unloading data into Snowflake, we have covered it. Using Snowflake databases, and queries, semi-structured data, time travel, streams and tasks. This database replication failover failback, right? I cannot do it. That is an extracurricular thing because in trial accounts we cannot do it. I can give you some theory part. I can send you some slide decks, and if you want to look at it, we can look. If I have time, then probably I can talk on this failover feedback. It cannot be done using this one. You have to raise a ticket to Snowflake for setting up, but I'll give you the theory part of it. Okay. And then sample data sets, we have looked at it. So data sharing, we have worked on the data sharing part of it. And then manage your Snowflake organization. This is nothing of this. This is something that I have taught to you. And then
Sir, if you have time, cover that part, sir.
Which one? Dates. Yeah, that's what I'm trying to see. Dates. I do have dates. And dates is also a little confusing, but okay, let's go on then look at this. Okay, let's go with this dates. Okay, so Snowflake, it treats dates very differently, and it's much more performance oriented when you're working on dates rather than strings. So Snowflake works pretty much fast with dates rather than strings. Okay, and the default format of date is right in Snowflake is y mmdd or ddmyn. This is the default format. The year, first, month, and the date. Okay, so Snowflake supports single time data type for storing dates, hour, minutes, and seconds. Okay, we have fraction seconds, precision 0 from 0 to 9 nanoseconds. 9 is it, so hours, minutes, seconds, and it will have this many number of nanoseconds. Okay. So timestamp is the default one for storing the date and time of it, and the timestamp has three variations like timestamp integer, timestamp tz, timestamp ltz. Okay. So what is ntz? ntz is nothing but no time zone. That means it's a wall time. So when you go and query this particular select star current timestamp. So if you look at it, right, this is the correct timestamp. You will have hours, sorry, year, month, date, day, hours, minutes, seconds, and then nanoseconds, and then the time zone. Okay, this is the default. And this what is the time now? 05:34. Now the time is 6:30. See, this is the Pacific Standard Time. Okay, in Pacific Standard Time is 5 o'clock in the morning. So whenever you create an account, right, the account will be pointed to a time zone. So by default, it points to Pacific time zone because that's where Snowflake is headquartered, San Mateo, California. California is PST, Pacific time zone. So by default, it sets to time zone, Pacific time zone. So if you want to have a different time zone, you have to go and change the time zone settings in the account. We'll see that. Okay. So time zone is nothing but, so when you go on, then if you can cast it, right, this is what we have, colon timestamp underscore ntz, no time zone. See, there is no time zone here, only until this is a wall clock time. Okay, and if I say tz, this is time zone, it shows me 07. And you have one more thing called local time zone. See, for me, the local time zone, because I did not set up any local time zone, for me, the local time zone and time zone is the same. For example, if you have something like Mumbai is a local time zone, and then time zone is PST, and you want to save some data in your local time zone, then you have to convert them into, you have to change the session that you are running in, and change your local time zone to set the time zone to your local, and then you can do it as well. Okay, there are three variants of timestamps. You can get no time zone, which is the wall clock time of thing, and then time zone is the date of timestamps. Time zone is the time zone. So, and whenever it's a time zone, it uses the UTC part of it. So UTC time zone. UTC is like, Greenwich Mean Time, GMT time zone. It was previously. Now they renamed it as UTC, Universal something. I don't know. So that is, and in comparison with the GMT London, they have from there they calculate. So India is -5 hours, and then the US is something. So from there, every so I think how do you change the time zone here? You can change the time zone for the date in Windows, right? There is something here where we can do. You can see sometimes time zone settings also for Windows, right? Adjust date and time is recommended English image. If you go back and then see Sunday, Saturday, June 5th. This is my regional thing. Same thing, you can have it in this one also. Okay. So time zone is associated with the UTC format, -7 hours. That is the PST of it. Okay. So local time zone is the data for time stamp with time zones in the current session. This is in the current session. If you want to set it up to Mumbai, right? Then you can set it up to Mumbai. Because I don't have the Kolkata is our thing, right? What is the spelling of Kolkata? Can it should be attack. Asia. Yeah. Kolkata, sorry. They changed it to Kolkata. Right? So current wall clock, different time zones, and you can set it up to Kolkata as well. So I have another example. There are only two places. So convert time zone, America, New York, current time stamp. Convert time zone, Asia, Kolkata. You can set up your, so there is, 1 second. One second. And, this is the one. For the local session, you can go ahead and change your time zone. Alter session. This is what is Kolkata, right? Which is Asia, Kolkata. So America, Los Angeles is the default one. So if you go and look at the parameters, right? Show parameters like percent zone, percent in account. These are all the time zone. What is the time zone? Default time zone that I have here. This is the account level time zone. This is America, Los Angeles. If you go and change it to any other, if your company is in central time zone, right? Or if your company is in India, you can go ahead and change it. So I'm going to set it up like this. Asia Kolkata, right? So what is the current time stamp right now? This is my current time stamp. Okay. I did not change it yet. I'm just trying to capture here. And point of if I got. So when I go and then use current timestamp, right? Plus 530. Can you see this? Current time zone. Even if you query this particular thing without the conversion, right? Like that. Because in this section, I've studied my time zone. Okay. Timestamp. Let's go to LTP. So there is no difference between local time zone and time zone. The only difference is, right, that shows in UTC format, it shows in a local format, something like this. Let me change it to time zone. I think there is no difference. That's one. I don't see any difference. Previously it was 7 o'clock, -7. So not 7 o'clock. The UTC difference is -7. Now it's 5:30. Plus 5:30. Okay. So time zone is different. So what is it? It stores. So this time zone, it helps. It does when you look at it, right? There is no difference in the way it represents the data. But whenever it stores the data, it stores the difference between the UTC time zone and this one. So let me read out. Snowflake does not store the time zone associated with the timestamp. Instead, it stores the UTC offset associated with the time zone, so timestamp. This sounds pedantic, but it has consequence we'll explore later. So I have some examples of it, why. But normally, so whenever you're trying to have your account set up, right, you normally store all your timestamps dates in respect with your time zone, whatever the time zone that you set up on your account level. And we don't use time zones or anything. We just use the wall clock and then store the data. Wall clock represents, you know, the time zone, right? For example, if you set it to PST and the times are all PST. Whenever you insert some data, if you're capturing the creation time or updation time or something like that, those are all in respect with the PST times based on your account time zone. Those times are all in accordance with your account time zone settings. So LTZ is the current session time zone used by Snowflake, local time zone. So this is nice idea because theoretically every consumer would automatically work with timestamps in their local time. So you can work. So whenever you're trying to save, whenever you're trying to do from Mumbai in your session, you can put it up and then you can save the time zone so that they'll get to know where this record has been inserted, what is the time zone on that. If you want to capture some time series data from different areas from the globe, then this one will help you out. Okay. So timestamp LTZ. So this some more explanation. It internally stores the UTC time with a specified position. All operations performed by local time zone. So it can be said like timestamp LTZ. Instead of writing LTZ, right? You can write like this. See the same thing. It's an alias. Timestamp underscore LTZ or timestamp LTZ is the same. So we are trying to convert your current stamp into this particular local time zone. Okay. Timestamp no time zone is a wall clock, no time zone considerations. You can say timestamp NTG update time. Okay. Date time or timestamp underscore NTG or timestamp NTG without the underscore, both all of them are same. TZ is a time zone. So it has the UTC time with an associated time zone offset. That means whenever it stores, right? It stores the offset. This is internal. You cannot see. You cannot view with your regular eyes. It's whenever it stores how much is the difference between the your account time zone and then this particular time. All operations are performed with the time zone offset. It stores only the offset of a given time. I never use this particular time zone. We use LTZ and NTZ, but I never come across the usage of this particular thing because I never worked on the time series of it and all this stuff. How this can help. Okay. So these are some of the formats. MON, abbreviated for monthly, number, digit, DD, day of the week, DY, 24, 12, AM, PM, MI, SS, FF. FF is fractional seconds, 0 to 9, 0 to. So if you want only one colon FF0, right? Something it gets, for example, if you say FF0 means it prints only 0. That means if the time is now 6:19, right? Then 18 colon 19, and then the seconds is some 30 seconds colon F0 will give you only 1 nanosecond. If you keep 9, it gives you 9 nanoseconds in the in your what do you call it, in the output, right? If you say F by default is 9, and then if you say F0, it gives only 1 nanosecond, and if you say F3, it gives you 3 nanoseconds. Dot 999 dot something something something. So based on, yeah, that is the precision that you want to do. 0 seconds to 9 nanoseconds. Specifying FF is equivalent to FF9. And this is the time zone format. TZH colon TZ mean time zone hours, time zone minutes, and you can write time zone hours, minutes together, and time zone hours. In the UTC format, specified plus or minus. Okay. So time formats. There are two time formats: ISO time format and internet time format. Windows uses internet time format for its purposes, and these are the examples. MISS FF is a fraction, time zone hour, time zone minute. So this is 9 digits, right? 1, 2, 3, 4, 7, 8, 9 plus you said time zone hour plus 07 colon minutes 00. FF, it gives you only 9 digits. If you say FF0, it gives only 0 here. FF2, it gives 1 and 2 here. Seconds is like this, MI until only minutes. So RPC, RFC time zone or internet time format, 12 MISS FF AM. FF means always it gives 9 AM, PM. So timestamp formats. So this is the timestamp format, and this T is the time zone, hour, minutes, seconds, F of the fraction of seconds, time zone hours, time zone minute. So Y by MMDD, Y by MMDD This is the time format. A timestamp format. From here it's time from until here it's date. So you can still use any of them, whatever the formats you want. And Snowflake uses Gregorian calendar. That means the starting year is 1582, and from there it calculates the calendar. This is kind of very, we don't use 1582, right? This is, and then because Snowflake does not adjust dates prior to 1582. For calculation involving dates prior to 1582 to match the Julian calendar. There are two, Gregorian and Julian. Snowflake uses Gregorian calendar. Date and time constants, also known as literals, support single quotes for dealing. So you can have a string and then you can have a date or a time constant of it. You can put whenever you're trying to convert, right? You can use that. And you can use intervals from this particular date. Give me an interval for 10 days, give me an interval of, so if you know the intervals of it, right, you can use the intervals of it. So interval 1 year. I have all the examples. We'll go through the action later. Let's look at the theory part of it. So integer interval, date time part. So date time part is the one which this is the function which helps you to convert into a different date, different time, whatever the format that you want. We'll see some examples of it. Interval 1 year represents 1 year from whatever the current date. So interval 1 year, 1 day. That means from now on, 1 year plus 1 day. First adds and then subtracts a year and then a day. So this will have an implications when you are working with end of the month. Okay. Interval, you can say that 4 years, 5 months, 3 hours represent 4 years, 5 months and 3 hours from the current time. Okay. I have some examples that will help you. Okay. And you can use the intervals using any of this year by by all these abbreviations you can use. If you want to come up with an interval of 10 seconds, interval of 1 month, interval of 100 minutes, you can use any of these abbreviations in your coding. So dates are arithmetic. Dates means you can have something like this, right? Select current date. It gives me the date 6/5, and you can say plus 10. It gives me or minus 10. This is what arithmetic is. You can do plus or minus with this particular case. Only dates, not timestamps. If your data type in your table is timestamp, you cannot do this. If your data type in your table is date, then you can do this arithmetic. Okay. And how do you convert into timestamp? See, time and timestamp values do not support simple arithmetic. You can add and subtract. How do you convert to an expression into the corresponding? To convert into local time zone, to no time zone, okay, to timestamp underscore tz or ltz. This is the one that we normally use if you want to convert into a local time. That means if this data is already saved in a different time zone and you want to convert into a different time zone, then you can use this particular things. Okay, so I have a lot of examples. We'll see action. So it might take about more than half an hour, and it's important as well. So tomorrow morning, let's look at these examples of dates. We'll see some action. It's already 6:30 now. I don't want to stuff too much for you guys. Let's catch up in the morning at 8 o'clock and then go over the conversion of dates, time stamp, time zones, all these examples, and then you can see. Okay. Are we good, guys?
Yes, okay, sir.
Okay. Right then, yeah. Let's catch up tomorrow morning. Okay.
Okay. Thank you.
Thank
No
you.
problem. Thank you.